So, question number 56 is on your screen. So, regarding cross-linked or network polymer, which of the following statement is incorrect? So, now we are moving to the solution part. So, they ask you about incorrect, and always remember when they, I already told the correct and incorrect they given. So, please mark it first. Now, this statement, this all statements are taken from the NCERT, that is the polymer chapter, which is given in your class 12. Okay. And if you see the option number 4, they contain strong covalent bonds in their polymer chain. So, this one is not related with your cross linked or your network polymers. So, your option number 4 is the correct statement of your question number 56. Now, we are moving to the next question, that is question number 57. So, question number 57 is on the screen. So, nitration of aniline is a strong acidic medium, also gives M-nitroalenil because. Now, we are moving to the solution part. So, if you see, they told you that nitration of aniline compound give meta-nitroaniline, and they ask you what is the reason. Okay. So, see, this is your aniline. And when it is treated with acidic medium, that is your H plus, this is the representation to show acidic medium, it is forming as anilinium ion. Here it is NH2 and here should be NH3 plus. So, this is your anilinium ion. Okay. And this anilinium ion, this NH3 plus is act as your meta directing group. And when it is treated with NO2, this will give the meta-nitroaniline. So, what is the reason? The reason of this NH3 plus, which is a meta directing group. Now, check the option. In spite of substitution, nitro group always goes to only meta position. No, this is not the correct answer of this question. Now, in absence of substituents, nitro group always goes to meta position. No, this is also not the correct option. In electrophilic substitution reaction, amino group is a meta directing. So, this is also not your correct option. If you see the option number 4, where it is written as in acidic or strong medium, aniline is present as an aleninium ion, and this is nothing but this is your anilinium ion, and because of this anilinium ion, this has acted as a meta directing group, and at the product we are getting as meta nitroalenine. So, option number 4 is the correct answer of question number 57. So, question number 58 is on the screen. So, which of the following oxide is most acidic in nature? Now, we are moving to the solution part. So, if you see, this is nothing but this is your alkaline earth metals. Okay. So, what is the mnemonics we are using to remember this alkaline earth metals? Beta, Mange, Kanya, Sundar, Bap, Raji. See, again I am repeating: Beta, Mange, Kanya, Sundar, Bap, Raji. Beta, Mange, Kar, Sundar to Bap, Roe. So, you can use any mnemonics. So, this is a good word: Beta, Mange, Kanya, Sundar, Bap, Raji. So, in this one we do not require this ASA part, again I am writing. Here we write beta, mange, kanya, sundar, the bap. Only these elements or these atoms are required. So, if you see in down the group, what will happen? The electronegativity is decreases, and electronegativity is directly proportional to their acidic character. I am using a different color for your understanding. Electronegativity is directly proportional to the acidic character. So, what will happen if electronegativity is decreases down the group? Your acidic character is also decreases. So, this is least acidic as compared to first one. So, if you see the option number 3 is the correct answer of this question, because beryllium oxide it's a least acidic, more acidic character than your barium oxides. Okay. So, question number 58, the option is 3. Next we are moving to the another question, that is question number 59. So, question number 59 is on the screen. The difference between the amylose and amylopectin is. So, now we are moving to the solution part. So, this question amylopectin and these are the direct question from your NCERT from 12th, and the chapter name is polymer. So, which one is the correct option, my dear students? Option number 1 is the correct option of question number 59. That is, amylopectin have a 1,4 alpha linkage and 1,6 linkage. Next we are moving to the another question, that is question number 60. So, question number 60 is on the screen. So, a mixture of 2.3 gram formic acid and 4.5 gram oxalic acid is treated with concentrated sulfuric acid. The evolved gaseous mixture is passes through KOH pellet, that is potassium hydroxide pellet. Weight in gram of the remaining product at STP will be. So, now we are moving to the solution part. So, if you see on the screen, these are the reactions they already mentioned. Okay. So, this is your nothing but this is your formic acid and this is your oxalic acid. Okay. And they give you 23 gram, 2.3 gram, sorry, 2.3 gram and another is 4.5 gram. First of all, we have to convert this into mole. So, if you do the divided stuff, you will get 1/20 mole. So, now this 46.03 and 90.03 is nothing but this is the molecular weight. Okay. So, how to convert it into mole? The given weight divided by molecular weight will give you the moles. Okay. So, here also it is coming as 1/20 mole. If this 120 mole is treated, so how much mole we are getting of carbon monoxide? 120 mole. Here also we are getting 120 mole of carbon dioxide and 120 mole of carbon monoxide. So, how many number of carbon monoxide here? Here is 1, here is 1. So, total 2 CO will be there. Okay. So, 2 CO. So, first we have to see the 2 CO and what is the mole? 20 mole. But your answers are given in the gram. So, again we have to multiply with the molecular weight with this, and finally, if you see we are end up here as 2.8. So, what is the remaining product of STP? That is your answer is 2.8. So, option number 2 is the correct answer of question number 60. So, how we find out the 2.8 I already discussed. Now, we are moving to the another question, that is question number 61. So, question number 61 is on the screen in the reaction, and reaction is given below and the electrophile involved is. Okay. So, this question is come from the phenol chapter of class 12 NCERT, and my students, you are easily understand this equation is nothing but this equation is Raman-Teimer reaction, and in Raman-Teimer reaction the electrophile which is generated is your option number 4, that is dichlorocarbon. I will show you how it will be generated. So, just concentrate on this part. So, CHCl3 plus NaOH. So, NaOH is base, so it abstract the proton. So, at the result we are getting CCl3 with lone pair and minus plus your H2O. Now, again this CCl3, by removing of Cl minus we are obtained as CCl2, and this is nothing but this is your dichlorocarbon. Sorry, again I written it CCl2 and this one. So, this is nothing but this is your dichlorocarbon. Okay. So, option number 4 is the correct answer of question number 61. Very easy, directly come from your NCERT, the chapter is phenol. So, question number 62 is on the screen. Carboxylic acids have higher boiling points than aldehydes, ketones and even alcohols of the comparable molecular mass, and it is due to their, means they ask you the reason why carboxylic acid having the higher boiling points. So, this question is come from the carboxylic chapter of class 12 NCERT, and what is the answer of this question? It is very familiar, the option number 4, that is the formation of intermolecular hydrogen bonding, and due to this intermolecular hydrogen bonding the carboxylic acid having a higher boiling points compared with others. Very easy statement and easy question. What is the reason? Intermolecular, remember as international, compare with intermolecular. Okay. So, the option number 4 is the correct answer of question number 62. Next, we are moving to another question, that is question number 63. So, question number 63 is on the screen. Compound A C8H10O is found to react with NaOI produced by reacting Y with NaOH and yields a yellow precipitate with a characteristic smell A and Y respectively. So, now we are moving to the solution part. So, if you see in the board, this is I am give you the simplified form of the question. Okay. So, what this? So, this is nothing but these are the simplified form of your previous question. Okay. So, I am just give you the idea what they ask you. So, this Y when it react with NaOH you will get this product. Okay. So, here NaOI and this NaOI is react with your reactant A and remaining we will get the product. So, what is I? First of all we have to find it out Y. So, Y is nothing but that is I2. Okay. I2 is the Y. So, you will get Y as I2. Now, find out the NaOI, what is this? So, they mention as an iodoform, yellow precipitate. Okay. So, yellow PPT is nothing but this is given by iodoform test. Okay, iodoform. So, how is the structure? Structure is CHI3. So, if we find out the CHI3 how it will get from here, we will end up with the structure of A. So, A is nothing but this basically your so is A is nothing but this is your secondary alcohol. Okay. So, when the secondary alcohol is react with NaOI, you are end up with ketone, that is basically a acetophenone. Okay. So, when this acetophenone again react with I2 or NaOH, you will nothing but you will end up with this, that is CHI3 plus another molecule is your benzoate. Okay. So, this and this you are getting the end up with as a product. So, how we will get it out? Because they are already mentioned as yellow PPT, and yellow PPT is given by iodoform test. So, the structure of iodoform is CHI3. So, how CHI3, if we will find it out, then we will easily get to know what is the structure A. I know it is little bit complex, because if you have knowledge of organic chemistry, then only you are able to find it out. Okay. So, if you know how to find it out, this one CHI3, that is iodoform, then you will easily get their option A. So, your option A is your secondary alcohol. Option number 2 is the correct answer, because see here I2 is produced and this is your secondary alcohol. So, option number 2 is the correct answer of question number 63. Okay. Now, we are moving to the another question, that is question number 64. So, question number 64 is on the screen. So, which of the following molecule represents the order of hybridization sp2, sp2, sp, sp from left to right atoms? So, now we are moving to the solution part. So, if you see sp2, sp2, sp and sp. So, I will give you a simple trick which is applied in all organic chemistry. So, it is a trick, it is not a concept. Okay. So, just remember. So, if they give you this kinds of compound, and they ask you what is the hybridization of this carbon. So, what you do? You just calculate the sigma bond, okay. Do not count the pi bond. So, here 2 sigma bond is there, then 1 sigma is go to S and another one is go to P. So, the hybridization of this carbon is sp. Now, similarly, if they given these types of compound, and they ask you to find the hybridization of this carbon. So, what you do? You just count the sigma bond, here 1 sigma, here 1 sigma, and in double bond only 1 sigma is there. So, 1 sigma is goes to S and remaining 2 sigma is go to the P. So, what is the hybridization of this carbon? That is sp2. So, similar concept we are going to use to find out this sp2, sp2 and sp. So, now move on to the solution. See here 1 sigma, 1 sigma. So, this carbon is sp. So, it is not possible because they give you the order, the first should come as sp2, but here first is come as sp, and they also mention the direction, that is left to right. So, left to right I have to move from this, from left to right. So, left to right the first should come as sp2. So, here come as sp. So, this is not our option. Now, in this case if you see, this is coming as sp2. Okay. Now, if you see this one also coming as sp2. Now, if you see this one also come as sp2, see, but you should require sp. So, option 2 again neglected. Now, option number 3, see this carbon as coming as sp2, this one also coming as sp2. Okay. This carbon is coming as sp because 1 sigma 1 sigma. So, this is as sp. Okay. Now, another is form of sp. So, see here is sigma 1 sigma and hydrogen is linked with this in this way. So, the hydrogen also give you the sigma bond. So, here sp. So, see now they follow the form direction also left to right, sp2 sp2 sp and sp. So, sp2 sp2 sp and sp. So, option number 3 is the correct answer of question number 64. Just follow this trick. Okay. So, this is trick, it is not a concept again. I am telling you, if they are giving, just count the sigma bonds, the first sigma bonds consider as S and remaining you have to put it on P. So, for this sp, for this 3 sigma bond is there. So, one is go to S, another 2 is go to P. So, question number 65 is on the screen. So, which of the following carbocation is expected to be most stable? Now, we are moving to the solution part. Okay. So, if you see this NO2 groups is nothing but these are minus I groups, and minus I groups are electron withdrawing nature, electron withdrawing groups. So, what they do? They always pull the electrons towards itself. Okay. So, they never favor the positive charge nearest to them, because positive signs is already said that they having the lack of electrons or lack of charge. Okay. If the lack of charge, then electron withdrawing groups are not favored for this positive charge. Now, if you see the option, this is minus I, this is minus I, this is minus I, this is minus. But here see the nearest position is positive charge is thus below this minus I group. So, this positive is not be stable. So, option 3 is get neglected. Now, option number 4 is also the same case, this positive again this minus I group nearest position. So, this is not possible. Now, if you see here this positive charge is this meta position and another one is a para position. Now, if you see the distance minus I group distance. So, see this is the smallest distance and this is the larger distance. The distance will increases, the minus I group effect will be decreases. Okay. So, if you see the distance will be more here. So, minus I effect will be lower if I am compared with the minus I effect of this. So, here the minus I effect will show major amount. So, that is why this carbocation or this positive charge is not stable. So, option 1 is not our answer. So, option 2 is the correct answer of this question because of the distance. Here distance is more. So, minus I effect of NO2 will be less, and if minus I effect of nitro group will be the less, the carbocation is whatever is present in this compound, it will be more stable. So, option number 2 is the correct answer of question number 65. Now, we are moving to the another question, that is question number 66. So, question number 66 is on your screen. So, which of the following is the correct with respect to minus I effect of the substitutions? Now, we are moving to the solution part. So, minus I effect. So, see it depends on the electronegativity. More electronegative, more minus I effect. So, if you see in the first option, option fluorine is the more electronegative if I am compared with oxygen and nitrogen, because nitrogen, oxygen and fluorine is come on your periodic table. So, if we go from this to this, the electronegativity will be increases, because the Z effective increases, and Z effective is directly proportional to your electronegativity. See, so electronegativity order is fluorine, then oxygen, then nitrogen. So, your option number 1 is the correct answer of question number 66. So, now we are moving to the another question, that is question number 67. So, question number 67 is on the screen. The type of isomerism shown by the given complex is. So, now we are moving to the solution part. So, if you see, this is your nothing but this is the coordination compound, okay, and is given to your NCERT class 12 chapter, that is coordination, one of the important chapter of your chemistry. And this ethylene diamine is nothing but this is your bidentate ligand. So, what is the coordination number of this? The coordination number is 6. So, in 6 coordination number we are getting 2 structure of this coordination complex. Okay. So, what are those? See, this is your central atom, now this and this and this. So, here ethylene diamine, here ethylene diamine, sorry. So, these 2 isomerisms you are finding. So, this was nothing but this is your trans, because these groups are opposite, and another one these 2 groups are close to each other. So, this is cis. So, cis and trans are nothing but those are the geometrical isomerism. So, option number 1 is the correct answer of question number 67. Now, we are moving to the another question, that is question number 68. So, question number 68 is on the screen. So, which one of the following ion exhibit DD transition and paramagnetism as well? So, now we are moving to the solution part. So, if you see which one of the following exhibit DD transitions and your paramagnetism. Now, for paramagnetism we have to need to find out the unpaired electrons. So, if you see in among the following 4 options, last option if you see MnO4 2 minus, what is the oxidation state of Mn? So, here if I am putting as X plus 4 into minus 2 is equal to minus 2. So, X minus 8 equal to minus 2. So, X is equal to plus 6. So, plus 6 is the oxidation state, means Mn 6 plus. So, what is the configuration we are obtaining here? We are obtaining here argon and 3D1. So, number of unpaired electrons is 1. But the similar way, if you find out the oxidation state of chromiums and this manganese, you will find out that they does not have unpaired electrons. No unpaired electrons, no unpaired electrons and no unpaired electrons. Okay. So, I will show you one thing, okay, from this one CrO4 2 minus. So, how we will find out the oxidation state? Again X minus 8 is equal to minus 2 and X is equal to plus 6. Now, if you see the chromium plus 6, the electronic configuration is similar to with your argon, okay, and argon are, we know that they are the noble gas. In noble gas all orbitals are filled. So, they does not have any unpaired electrons. So, if unpaired electrons is not there, they are not showing any paramagnetism. So, that is why this first option, your third option and your second option is been neglected out, and only one option we have left it out, that is option number 4, and this is the correct answer of question number 68. So, my dear students, today we are learned lots of chemistry, lots of chemical equations and see lots of periodic trends also and solving many as much questions. Okay. So, next class we are going to more digging into the chemistry and learn more number of concepts regarding chemistry. So, till then keep learning, keep revising. Thank you.